This is a very short presentation, so I have to kind of get started quickly about microbenchmarking. I want to introduce JMH, the Java microbenchmarking harness. Anyone using it? Heard about it? No one. Interesting. My name is Hardy. I work for JBoss. I'm part of the Hibernate team. I think that's enough for introduction. I have no affiliation whatsoever to this tool. It's actually provided by written by the OpenJDK development team. But I kind of use it more and more, and I think it's a very valuable tool. I want to have a little bit of motivation, an example I want to use for this introduction. As part of Hibernate, I'm the Hibernate Validator team lead, and I got a Jira request saying that the URL constraint, so something like this, you can put it on a string, add URL, and when this string gets validated using Hibernate Validator, it's basically checking, is this a valid URL, a valid HTTP URL. And the way it does it at the moment is it creates a Java net URL constructor, and if this succeeds, it's valid. If it fails and throws a malformed URL exception, it's invalid. And this Jira report claimed that's not performant because there's a lookup of stream handlers, and the regular expression would be better. The thing which kind of got me here initially was this statement where it goes, in terms of performance, it's costly to look up the stream handler. And I was like, sure, it's costly, but if I'm the implementer of a JDK or a JVM, surely I would only do that once. I would go, this is an HTTP URL. I have to look up the stream handler. I do it once and then cache it. And so I was kind of a little bit interested, and so I have to kind of check this out a little bit more. So I want to write a benchmark. I want to know what's better, kind of validating a URL using the URL constructor or a regular expression. A little sidebar, a little sidetrack. So how hard can it really be to write a micro benchmark? It's super simple, right? Let's take a completely different example. Say I want to know performance-wise which is the best set implementation to add elements to. So I could kind of go, okay, I create a list with 3 different implementations of a set, a hash set, a tree set, and a concurrent skip list set. And then I iterate over this list, and for each of these set implementations, I call do benchmark. And benchmark is extremely simple. It kind of creates a timestamp. It runs from 0 to max elements, which is 10 million in this case, and just kind of adding elements. And at the end of the loop, I'm kind of taking another timestamp and subtract the 2 times. At the end, I should be able to see which is the best set implementation, right? No. It's not that easy. What problems could there be? Some of them, garbage collection. If I do that in the same JVM as seen, the first set implementation gets an empty heap, can easily add elements, but maybe then the second set implementation has a full heap. And now kind of garbage collection kicks in, so I have a skewed result in the performance test. Another thing which also in this example could play a role is the JIT. There's no warm-up or anything. I kind of just take the timestamps and run the performance tests. What happens if the just-in-time compiler kicks in and kind of changes the code? So then maybe in the first set implementation, this just-in-time compiler has not kicked in, no optimized code, but then on the second set implementation, it has optimized some code. Even worse, anyone heard of OSR? OSR, on-stack replacement. The just-in-time compiler, the JVM, can not only replace interpreted method once it's executed, it can, while it's executing, while it's kind of stuck in some sort of loop, it kind of goes, actually, I should kind of compile it to native code and on-stack replace that. And if you don't control that, you kind of get skewed results. And then maybe not so relevant for this example I just had, it's dead code elimination. If I write a dumb performance test case where I kind of go, I just calculate some numbers or some sort of thing, but then throw it away without using it, the just-in-time compiler can actually go, that's dead code, I can eliminate that completely. Also things like system load, that's something a little bit out of the control of the framework, but that's something to think about. If it's a longer performance test, I start running it, and then suddenly halfway through some sort of background process kicks in, or I start doing something else. That's not something you should do when you're doing a benchmark. So you have to know what your machine is doing, and you should probably not, while the benchmark is running, start kind of transcoding a video or something. Okay, so enter JMH, so Java Microbenchmarking harness. It's developed by the JDK team, which is, for me, very important because these guys know what the just-in-time compiler is doing, and their framework takes actually measurements to avoid certain pitfalls other frameworks maybe have, or like your homegrown framework maybe has. The lead is Alexei Shipilev. If you search for him, there are several videos he's giving a talk about performance and about this framework. The current version is 1.3, and it goes very fast. This little tool gained a lot of traction within a year. Google has another alternative, but JMH, if you read a little bit on the net, seems to kind of be the preferred choice for many nowadays. One way to get started is this way, with a Maven archetype plugin. It's basically one long command line where you kind of say you want a JMH Maven project, and what this kind of command line creates is an empty project shell with one single class. It's all kind of pre-generated, and in this class you can start cut and paste or writing your benchmark code. A little bit of warning: this particular shell is not using the latest version of JMH. So if you kind of go down this way, you want to make sure that you go into the POM XML, which is generated, and update to version 1.3, the latest JMH version. I'm not sure why the latest version is not using this archetype is not in Maven Central. Okay, now it's time to have a look at some code. JMH, it's mainly annotation driven. So, and the main annotation is basically you just need a class and you annotate a method within the class with @benchmark. You're saying this method in here is a benchmark, and that's all to it. If you leave everything at the default, you can already run this method, this annotated method, as a benchmark. Then there are things like @fork, which tells harness to create a fork JVM to kind of get a clean slate. You can also say fork 0, everything is run in one JVM, but the default, and probably in most cases the better option, is like I'm forking a JVM, I want to have a clean slate for each single benchmark. Then there are some sort of, let's call it more global annotations. The benchmark mode, in this case mode average time. So what do I want to measure? I want to have the average time, how long it takes one of these methods to execute. I can have also this mode throughput, and then there are two more modes. And now here comes one of these first things. You want to have, you can have a warm-up. You can specify how many iterations of these benchmark methods do I do without any measurement, and then how many iterations of this benchmark do I do that for the actual measurement. So in this case, I have one warm-up iteration and 2 iterations which are then getting measured. And you can specify things like do I want to have milliseconds, nanoseconds, seconds, whatever time unit you want. Back to the benchmark. It's actually quite simple. I have two methods. The first one, regexp, I kind of highlight the whole thing. That's the one which is supposed to test, coming back to my URL validator thing, validating a string using a regular expression. And URL constructor is doing the same thing by using URL constructor. How does it work? There are now a little bit more annotations. And now we're looking at state. State is a way to kind of get state, or the data you need for your benchmark, into the benchmark method. It's a recommended way. It also creates a scope. It's like, is the state for the whole benchmark or per thread? In this case, here I create a new URL. If there's no exception thrown, I return true, otherwise false. And here you see, here's this URL approach. And what JMH does, it kind of matches this kind of state object by type, and it basically just injects these kind of things into the benchmark method. And the last piece to kind of to complete the whole benchmark is this bit. It's another state object, it's also data which kind of is needed for the benchmark, but it also makes use of add_param, which is a way to run the same benchmark with different input parameters. So what's going to happen is this benchmark is being run 6 times because I have 6 elements in this array. And for each run, I get a new instance of URL holder where the string URL is one of these six URLs I'm specifying here. It's very genuinely test limit the same concept and test ng as well. That's about it. So that this is kind of how things come together. So how do I run a benchmark? There are multiple ways. I can just do something like this. It's some sort of fluent API. It's an option builder. You kind of create your options. In the simplest case, you just point out the class which contains the benchmark method, and then you go new runner, run. That's, for example, if you want to integrate it in JUnit, or you want to run it directly from your IDE. So kind of it's doing something. I keep going. The recommended way of doing it is actually via Maven. You see in the background, if I pull that up, it's actually running the benchmark in my IDE. But and now it's so what the Maven setup is doing. It actually builds a jar file, a shaded jar file, which is always the same name. It's called benchmark.jar. So if I now go java-jar target benchmark jar, it's actually doing now the same. Okay. It can't run two in parallel. Now it kind of runs the harness on the command line. The interesting thing is also there is a whole bunch of things you can control from the command line. You can change the output format, comma separated file, whatnot. You can change the time units on the fly. You can change the warm-up iterations or the measurement iterations. So you can do a lot. Once you have this single jar file, you can control a lot of the things which are kind of preset in by annotations. You can override it to kind of play with different parameters. Right. So short summary, JMH is annotation driven. There's a bunch of annotations which kind of configure benchmark. The most important one is add benchmark. Technically, under the hood, there is a whole bunch of annotation processors which take your benchmark method, and for each benchmark method, it creates a class and kind of wraps all sort of timing and all these kinds of things, everything which is required for the benchmarking around it. Per default, it creates this shaded jar, this one single jar file, which you can execute to run the benchmark, and you can configure via annotations. You can run it or configure it via the Fluent API, or you can use these command line flags to change behavior to drive the benchmark. So now back to my example. If I do that with URLs, kind of testing the performance regular expression versus I should go back. Most of you probably have seen, but I guess what's faster, URL constructor or regular expression? No one wants to take a guess? Actually, if it's a valid URL, the regular expression sucks by far. The blue line is regular expression, and then the other 3 lines are 3 different variants of the URL constructor. It looks different if it's an invalid URL. Then the regular expression is better. Any idea why? Is it the stream handler? Nah. The stream handler is caged. It doesn't make sense to kind of look it up all the time. But any ideas why it's slower?
It's faster.
It's the stack trace. So what I'm doing is like I create a URL instance, and if it's not valid, I catch the malformed URL exception. And creating the stack trace and filling in the stack trace information. That's the thing which makes it slower in the invalid case. So that's interesting. And I can change that. So these other 2 bars you're seeing, it's like this yellowy kind of thing, kind of takes already time back. And if you look at the green one, we are very close to the performance of a regular expression for the failing case. And if I quickly go back here, I'm using two. So another thing you can do with JMH is you can pass in Java JVM arguments together with the add for. And in one case, I'm using max Java stack trace steps 6, so I'm reducing the amount of information which goes into a stack trace. And then in another case, which unfortunately in this version of JMH doesn't work, I have to use an older version, but it's JMH which fails me here. If I disable completely stack trace in throwable, so when an exception is thrown, no stack trace information is added to the exception. If you go back here, you see that the results kind of get completely different. So the green one is without stack trace, and we are very close to the performance of a regular expression. So actually, I think the URL constructor one is the better approach, because I believe in most cases you're dealing with valid one, hopefully. But talking about the stream handler in this case was completely nonsense. It does not play any role in performance. And that's what I'm kind of getting at, kind of makes these kind of statements. It's not enough, oh, a stream handler kind of drags down performance. That's not the case. Anyways, there are some links. There's a great Daniel Mitterdorfer, second URL. He has a whole range of blog posts, like whole series about JMH. It's a really good entry point to learn more about this tool. As said, the tool has a lot of traction, so there are a lot of tutorials out there nowadays. You also can find this particular example and the slides on my GitHub account, JMH perf tests, if you like. Another thing is just, this is actually the random expressions I suggested. So on top of, I don't know how to maintain. If anyone ever will find an error in here, I have no idea how. I mean, I consider myself quite okay with regular expressions, but this is a beast I don't even. And the problem is, like, you know, it has to, if you kind of decode and it's all Unicode, you kind of have to handle URLs and all sorts of kind of encodings. I mean, honestly, what do you do with that? That's it. Do you have any questions? So if you have this kind of question, like what's better, what's kind of a better algorithm, what's kind of a better data structure, instead of kind of making gut feel decision, it's super, within under an hour you have a simple harness where you can plug in these two different alternatives and get real facts, real numbers. So check it out. Thank you.